Today we are going to discuss on a C program for embedded structure or nested structure. Here embedded or nested structure means a structure in another structure is called embedded structure or nested structure. So here structure is a group of different type of data. Here you see here, for example, if I take here the structure, here in the structure we can write different type of data. Type means data types. Here in the structure we can write int, float, char, and by using arrays we can access multiple records in this. Okay, for example, int roll number, character, string of 20, str of 20, or name. Okay, that means str means name, char name of 20, that means name. We can access the name. We can access character, integer type, float, different types of the data we can encapsulate in the structure. Not only we can write here float, we can write int, float, char, strings, all we can write in this. So here structure is a different type of data. That means structure is a heterogeneous type, heterogeneous data type of the values. So here struct is a keyword. Here this is the, after struct is followed by user defined name. You can write any name, that's your choice. This is called, this struct is a user defined name, reserved word or keyword or predefined word. The meaning is existed already. Whenever we write the struct, one structure will be formed, structure will be created. So in that we fill the data, we encapsulate the data. Why we are encapsulating means to provide the security of the data, we encapsulate in that. In this structure we can write different type of the data, different data type values we can encapsulate in a structure. So here struct is followed by user defined name. You can give any name, no problem. Okay, so this is called user defined name. User can define their own value, their own name. Okay, so here I have given substructure. Okay, here I have taken main structure and substructure. Okay, so here in this structure we can write different type of the data, and struct is followed by user defined name. User defined name is followed by left and right curly braces. In this we encapsulate the data. These left and right curly braces are followed by semicolon. That means we are locking. Okay, here this, in this what we write, the type of the data are called members or fields. Here I have written only one type of the data, float type. So this is called member or field. If we write int, float, char, all they are members or fields. Here I have written only one, so it's called member or field. Okay, so here I have taken two structures. This is one structure, this is another structure. Okay, here I am going to encapsulate another structure in a main structure. Here you see here, this is the main structure. In this main structure I am going to encapsulate this substructure. I am going to inserting this substructure. So this insertion of substructure in a main structure is called embedded structure or nested structure. Collection of structures. Inserting one structure in another structure is called nested structure or embedded structure. Here you see here if I want to access this structure, here I will use, here we can write S. This S is the, this S is the, you see here, this, you see here, this S is the structure variable. Here this Y is the, this Y is the member or field. This S is the, this S is the structure variable. By using this structure variable only, we can access this data. Without this structure variable, we cannot access. Earlier, we can write directly Y is equal to 2.3, but now it's not possible. How can I access this Y value? S dot Y is equal to 2.3 or 7.9, any value, but S dot Y. So, if I want to access the structure data with the structure variable only, it's possible. S dot Y, then only it's possible. Okay. So here, now here I am going to inserting this substructure in the main structure. That's why here I have written here in the main structure. The meaning of this is, here I am inserting this substructure in the main structure. I am going to insert, this is the, this substructure is in blue color. Now I am going to insert this substructure in the main structure. This is the main structure. In this main structure, you see here, I am going to insert this substructure. Okay. Either we can write structure variable here or outside of that also. Okay. Or we can write here yes, like this also we can give, or we can give structure variable like this, struct sub yes, like this also we can declare structure variable. Now if I want to access the structure data, S dot Y is equal to 7.9, like that we can give. But now our aim is inserting one structure in another structure. So I am going to insert this substructure in the main structure. So I declare structure variable in the main structure. You see here, struct, structure name, user defined name, and structure variable. This S is the structure variable. You can take any variable, T, P, X, Y, A, B, C, any variable. Okay. So here in this main structure, I have taken X value. Okay. This M is the structure variable of main. This is the main structure. For this M is the structure variable. Okay, this M is the structure variable. Here I want to access 3 records. For that purpose, here I have taken M of 3. If I give M of 3, I can access 3 records of the structure. No need to write 3 times this structure data. Once you write M of 3, you can access 3 records of this structure. Okay. So that is the advantage of the structure. Only once you write as many as times you can use the data of the structure. That's why here I have taken array with the structure variable array. So here, what is the definition of the structure? Structure is a group of heterogeneous type of the data. Struct is a keyword. Struct is followed by user defined name. User defined name is followed by left and right curly braces. Left and right curly braces are followed by semicolon. These structure members or fields are accessed by structure variable. Okay. You see here, structure can be defined outside of the main or inside of the main. You see here, I defined this structure outside of the main. Either you define outside of the main or inside of the main also you can write. Here I defined these two structures outside of the main. Either outside or inside of the main we can define the structure or structures, no problem. Okay, union also similar to write. You see here in the structure all the variable values will be stored in different locations, but whereas in the union only single memory location will be there, last value will be displayed properly. Okay, remaining values, beginning values in the union will be stored in the garbage location. That means we will get the garbage values in the union. Okay, in the union only one location, single location. In the structure different locations will be there for the to store the members of the structure variable, structure values. Okay, you see here, now we inserted substructure in the main structure. Main sub is the substructure, main is the main structure. That substructure is defined in the main structure. Okay, next int main. Okay, actual execution will begin from the main function. For I is equal to 0, I am going to access maximum 3 records. You can access 1 record, 2 records, but maximum possible 3 records. If I give here 1, 2 memory locations will be wasted. 2 set of records we cannot enter. If I give m of 1, if I give m of 3, we can access 3 set of records of the structure we can access. Okay, here you can use student data also in the structure. For example, if I want to access 60 students data, here we have to write int roll number. Okay, char s of 20, that means 20 characters we can store. Last character is the null character. Okay, date of birth, all the data we can write in the structure. We can access with the structure variable using with the array. Okay, if I write 60 set of records we can access. If I write 3 set of records we can access this integer and float data. In the main structure int is there, in the substructure float is there. Now I am going to access. How can I access? If I want to access this x value, m dot x. If I want to access this y, m dot s dot y. Why? Because the substructure is there. The meaning of this is, now the substructure is there in the main structure. That's why if I want to access the substructure data, m dot s dot y. If I want to access main member of the structure, m dot x. Okay, you see here I declared integer I for loop. This is the initialization, condition, increment. Enter x and y values for the main and substructure values. Okay, here I am going to read through keyboard by using scanf function. Scanf is the formatted function. Here f stands for formatted function. Okay, here scanf is the input function, input formatted function. Here number order type should be matched in this. That's why it is called formatted function. Here you see d, integer. Type specifier for the d is integer. Type specifier for the float is f. Here m of I dot x, I am going to access 3 records. That's why m of, you see here for this x, m dot x. For that y, m dot s dot y. You see here m of I dot s dot y. I am going to access substructure data. Okay, first we have to take main structure variable, next substructure variable, after that member. Here for this x, main structure variable, after that main structure member. Like this we access. Okay, if I give ampersand at a particular location in the memory, at a particular address, the value will be stored. Here I am using for loop to store 3 records. 0 less than 3, yes. First time m of 0, m of 0 of x, m of 0 of s dot y. First record. Next I will be incremented 1 less than 3, yes. M of 1 dot x, m of 1 dot s dot y. Second set of value, second record value. Next I will be incremented as 2, 2 less than 3, yes. M of 2 dot x, m of 2 dot s dot y. Okay, you see here, once I write the data in the structure, I will use as many as times by using this for loop. No need to write 3 times. Once you write, as many as times you can use. Okay, here maximum 3 records. That's why here I have taken here 3 only. You can take any number of records. Okay, after iterating this for loop, we will come out from this loop. Okay, if I write in the loop only one statement, no need to write left and right curly braces. If I write more than one statement in the for loop, this left and right curly braces are mandatory. Okay, after coming out of the cursor of the control from the for loop, okay, till the condition is true, the for loop will be iterated. Whenever condition false, control comes out from the for loop. Okay, now the values are stored in the memory. Now I am going to display on the screen. Okay, for that here I am going to display by using printf output function. Printf is the formatted, in the printf f is the formatted function. It's output formatted output function. This function is used to display message on the screen. In the double quotes of the printf, you can write either capital letter or small letter. No need to use either small or capital. Here capitals and small, lowercase and uppercase are accepted. Okay, actually C is lowercase only, case sensitive language. But here in the printf double quotes, you can give either capital or small. But outside of the printf, you have to write in small letters, lowercase only. That's why it is called case sensitive language. Now I am going to displaying x and y values. Okay, backslash and cursor goes to the next line after displaying this message. Now I am going to display 3 records data. That's why I is 0, 0 less than 3. You see here, first m of I dot x. X is the integer type. So here number, order, type should be matched. Number of variables 1, 2. You see here x and y. In this order only we have to give first integer, next float. First integer, next float value. Okay, you see here next float. First integer. Okay, second float. So this is a number of variables 2. Number, order, type should be matched in the printf and scanf. Okay, you see here 2 number of variables 2, order. In the same order we have to give type should be matched. Number, order, type should be matched in the printf. This in what we write in double quotes, that is the control string. Okay, these are the arguments, these variables. M of I dot x, m of I dot s dot y are the variables, arguments. Okay, this is double quotes is the control string, these are the arguments. Okay, right, after that this loop will be iterated 3 times. M of 0 dot x, m of 0 dot s dot y. Here integer value, here float value. Next I is 1, m of 1 dot x, m of 1 dot s dot y. Next I is 2, 2 less than 3, m of 2 dot x, m of 2 dot s dot y. Here x is for integer, y is for float. Okay, this loop will be iterated 3 times. After that condition will false. Then control comes out from this loop. Here for one statement, this left and right curly braces are optional. After displaying the result on the screen, we will come out. This return 0 means int main. That main function will return 0 value after successfully compilation and execution. After getting the result, okay, the program will be erased from the main memory. Okay, this compiler will inform to the operating system with the 0. That's why this function will return 0. Okay. Actual execution will begin from the main only. That main will return integer value. Void means void also data type. That means dummy. It will not return anything. What we write in the function in the program, that will be displayed as it is. Void means it doesn't return any value. Void is a data type. Void means nothing, dummy. It will not return anything. What we write in the program, that will be displayed. But here I have written integer. This main function will return integer value, that is the 0. Okay. This main function will, compiler will inform to the operating system after successfully compiling and executing and getting output, the program will be removed from the main memory. Anyway, we saved in the secondary storage device with the file name.c. Okay. So after that the program will be ended with this. So now I am going to show how the execution will be there. You see here, I will compile the program. You see here, 0 errors and 0 warnings. After that I execute or run a program. You see here, it's asking enter x and n values. 1, enter 2. If I give 2, 2.0. Okay. Second value is the float value. Okay. Next 3. Next 4.7 I will give. Okay. Next I will give 6. Next 9.3. You see here 3 set of records I have given. Okay. Displaying x and values, x and y values. You see here, displaying. You see here, you give any values 1, 2.5, next 4, 7. If I give 7, 7.0. Okay. Next I will give 9. Next 45.67, 45.67. Okay, 3 set of records I have given. You see here, displaying x and y values. First one 1 and 2.5. Second set of record is 4. I gave only 7, but second one is the float. If I give 7, it's considered as 7.0. Next I gave 9 and 45.67. Okay. So here the values are displayed here. Okay. You see here, this is the output. Thank you for watching this program. If you like it, please share and subscribe.